but you gotta keep your head up. Oh, and you can let your head down. Hey, you gotta keep your head up.
Well, welcome back. Keep your head up today. We're going to tackle known cross sections, specifically of triangles. So I just wanted to take a moment and review some basic terminology with triangles. A lot of times we'll be talking about a right triangle, so this would be my right angle. And across from that nice long edge, we call that the hypotenuse. And these other two sides, we refer to them as the legs of the triangle. Okay, now there are several different types of triangle. There is the equilateral triangle. There's an isosceles triangle, a scalene triangle, where all the sides are different lengths, and you'll hear us talk about several of them throughout the week here. The other thing they're going to refer to a lot is the base, and hopefully you recognize that as the one going across the bottom. Okay, so let's recall that volume equals the integral of area. That's all we keep saying over and over. Volume is just the integral of area. And our focus today is on a triangle. So what is the area formula for a triangle? Well, that's nice and easy. 1/2 base times height. So when I do my slice analysis, I always need to identify the base and the height. So there's three main triangles the AP is going to focus on, and our goal is to kind of just get the kinks out of all the wording on them. So the first one, and get it down exactly, is an isosceles right triangle with the leg on the base. So I want you to underline a few things here. Isosceles, right, leg on the base. All right, and those are the three things we have to tackle. So right triangle obviously means it's coming to a nice 90-degree angle. Isosceles, to refer to that, or remind yourself here, that is two equal sides and two equal angles. Okay, so two things, two equal sides and two equal angles. And now leg on the base is key. Okay, so I'm going to draw what I think it's describing here. My isosceles right triangle, leg on the base. So this is the base, the bottom of my picture, where it has a leg, not the hypotenuse. So there's one leg. It's isosceles, which means the two legs are equal. And this one is the nicest and the easiest. And again, I would sketch them every time. And when I sketch it and I draw in my little tick marks for the isosceles, I can see that the base is equal to the height. And that is the key. So if it's isosceles, right, leg on the base, we have to know that the base is equal to the height. And again, I don't think you have to memorize it. Draw the picture, and it's fairly obvious. All right, our second big triangle, and it's worded slightly different, so get it down perfectly. An isosceles right triangle with a hypotenuse on the base. So again, notice we have that same isosceles right, but here's the difference. The hypotenuse is on the base. So now again, I can't stress, like you don't have to memorize these, but you do have to draw them out so they make sense. So this one's slightly tougher than the previous one. So let's just slow down and talk about where this is coming from. If this is the right triangle, that would be the right angle. Hypotenuse is across from it, so let's put a big H there in your notebook. If it's isosceles, then the two legs have to be the same. Notice where your legs are. Let's go ahead and mark those. These two legs have to be the same. Okay, so now let's go back. This is isosceles right, which then makes each of these angles 45 degrees. Okay. Now, let me just be clear. This H stands for hypotenuse, not height. Okay. So I'm going to refer to this as the base because it said hypotenuse is on the base. So let's put a big B here for base. And the height goes from that top vertex straight down. So let's put a nice H here for height. So hopefully I haven't thrown you off at all yet. So I made a nice isosceles triangle, meaning these two angles are equal, meaning these two sides are equal. The bottom part's called the base. Straight down is called the height. Now, this is very important. Look at what this height just did. It split this 90-degree angle up here in half, which now makes this a 45 and a 45. So now I actually have another pair of isosceles triangles because each of these base angles here and here are 45 degrees. So if these two angles are equal, then guess what? so are these two sides. So I'm going to kind of just pull apart what we created here. And again, if I'm going too fast, go back and replay this. I'm basically saying this triangle that we just created on this side is isosceles also, so these two are the same. So this is the height, but right here is not the entire base. This was the entire base. So this is how much of the base would you say? I would say it is half the original base. Okay, so I just pulled out this triangle, and I'm saying this bottom piece here is half the whole base. So my area, my ratio here that I have to understand is the height equals half the base. Where in that previous example, the height and the base were equal. In this case, when the hypotenuse is on the bottom, the height is half the base. Box that, get that highlighter out, let's star that. Okay, so the third and final triangle is the equilateral triangle, probably the toughest of the three. And this one sometimes is just easier to memorize, but I am going to draw it out and show you exactly where these numbers are coming from. So equilateral, of course, means all three sides are equal, so I can go ahead and put a tick mark on all three sides. And not only are all three sides equal, so are all three angles. So 180 divided by 3 gives me an angle of 60 for each one. Now remember, the area formula is 1/2 base times height, so I have to compare the height to the base of the triangle. So I'm going to go ahead and put a nice big B here for base. And it's equilateral, so we could pick any number in the world that we wanted this to be. Let's pretend the base is a length of 1. That would mean all these sides have a length of 1. If the length was 10, they'd all have a length of 10, etc. And I'm going to go ahead and draw in that height and label that in H. So probably the easiest thing to do is pull apart this triangle, just like I kind of did on that last example. So I'm just going to draw the right-hand side of this equilateral triangle. So that creates this right angle. This is still the height. Now let's use some common sense here. If this angle was 60, triangles are made up of 180, that's a 90, that makes that a 30. How convenient that this is 30 and 60, and those are the trig values you have to remember. All right, so if we said that this had a base of 1, let me just get my highlighter here. If this whole thing has a base of 1, and you took half of the triangle, we would definitely say if this was a length of 1, this would now be a length of 1/2. Okay, I took half of that triangle, which was a base of 1. If you put 10, then this would be a 5. All right, so the question is, if the base is a half, what is the height? Okay, so we need to figure out that length. Now, this distance here, did this change in my picture? No, so that is also a length of 1. So I'm just going to use some simple trigonometry to figure out how tall this is. So I'm going to put an X here for my question, and I'm going to mark my angle, and I'm going to say I'm looking for the opposite, and I have the hypotenuse. So I'm going to say the sine of 60 is equal to X over 1. So the sine of 60 is radical 3 over 2 is equal to X. So I would say this height is radical 3 over 2. So what does that tell me? The height is radical 3 over 2 times the base. So let's go ahead, star that, highlight that. This is the one we've got to remember, that height is radical 3 over 2 times the base. Now you can draw it out and get it on your own, but it might be easier to kind of memorize that one. View here with the equilateral triangle. So you can see I have my equilateral triangle between f of x and g of x here. So equilateral, again, implying that the lengths of these sides of this triangle are all equal. And again, I can change the view here, hopefully rotate it for you to get a better view. And our goal here is to slide or create more triangles as I go through. And I'm going to slide them across, filling this up into a three-dimensional shape. So you can kind of see, again, when I turn it, exactly what it's looking like. So there's kind of a bird's eye view. There's that side view. And we're filling that shape up. Again, we're not rotating. We're filling that shape up with whatever shape we pick, in this case, equilateral triangles. So let's go ahead and do a quick recap here. An isosceles right triangle with a leg on the base. So I'm going to draw it. I'm not memorizing things yet. Isosceles right, leg is on the base. Mark my two sides that are equal. And remember, you're always comparing the base and the height. Notice those are the two tick marks. So I'm going to say the base is equal to the height. Isosceles right triangle with the hypotenuse on the base. Again, I'm going to draw it. Those are my two equal sides. I'm going to put my height in and compare it to the base. My height is half the base. And then that third one, that equilateral triangle that has that goofy radical in it, if those are all equal, I'm picturing 60 here, and this is half of it. So I'm going to say the height is radical 3 over 2 times the base. All right, so we're going to do a very generic example here. F of x equals x squared. So obviously 0, 0 faces upward like this. 8 minus x squared. So I'm shifted up 8. This is an upside down parabola. So I'm going to go up 8, upside down parabola. And like I said, very generic. I'm literally going to say this is going to intersect at A. This is going to intersect at B. I'm going to shade that section in, of course, and then I'm going to draw my slice in. So I'm going upper minus lower. And again, I'm picturing an isosceles right triangle with the leg on the base. So I kind of have to picture it coming out of the paper like this at me. Okay, so again, volume is strictly the integral of area. So in this case, the area is a triangle. So my formula is 1/2 base times height. So I need to compare the base to the height. And again, I'm just going to sketch it out. Isosceles right triangle, leg on the base. Leg on the base, isosceles right. These are the two equal sides. So the ratio I have to know is that the height is equal to the base. So my base is upper minus lower. So that's g of x minus f of x, because it's the blue minus the purple. And my height is equivalent to that because we just said the base is equal to the height. So that's g of x minus f of x. My area formula, so I'm going to start with that again. I keep writing it for myself, is 1/2 base times height. So that's 1/2. Now it's whatever I wrote down for the base times whatever I wrote down for the height. Notice they're exactly the same. There's nothing extra there. So I'm just going to say it's g of x minus f of x squared. So then I can say my volume is just literally whatever I wrote for area. I'm going to integrate that. 1/2 g of x minus f of x squared dx. And we're going to go very generic. This can move all the way to the left from A and to the right to B. And again, we're not going to evaluate anything. Our goal is just to set it up tonight. So we're going to use that same scenario, the same two functions, but this time we're going to talk about an isosceles right triangle whose hypotenuse is on the base. So again, if you want to memorize them, that's great. I think the two isosceles are very simple just to draw out and get. So again, I'm going to draw it out so I don't have to hesitate, and I know how to do it when I get stuck in a month from now. So isosceles right triangle, hypotenuse on the base. So hypotenuse is on the base. Make my triangle. These two sides are equal. I'm comparing this base to this height. So your choices are either they're equal, it's half, or it's the radical 3 over 2. In this case, visually, I hope you can see that it's half. So I know that my height is half the base. Okay, so area equals 1/2 base times height, using the same feature in your notes from before. My base is that g of x minus f of x, so looking at that previous picture. My height, so now here's my new ratio. I have to say it's half whatever I wrote for base. So it's 1/2 g of x minus f of x. And my area then is the base times the height times 1/2. So I'm going to put in my 1/2 for the area formula. Now it's whatever I have for base times whatever I have for height. So I'm going to put it in here. I have a 1/2, and then I have a g of x minus f of x and a g of x minus f of x, so I'm going to call that g of x minus f of x squared dx. No dx because I'm not integrating. This is just area. So one more time, this is the 1/2 from the formula 1/2 base times height, and there is my base and my height being multiplied in there. So volume then is just that integral. We called it from a to b. I can clean that up and call that 1/4 g of x minus f of x squared. Now I need that dx. All right, the last example, again, following the same functions, the x squared and 8 minus x squared, we're going to talk about that equilateral triangle. So one last time, I'll kind of draw it out for you so you remember where it comes from. I had my 60, 60, 60, and I want to compare the base to the height. So again, I cut this in half, so I called this base a half, and I wanted to figure out what that ratio is there. So hopefully you can remember it. If not, write a trig function for yourself, but the height is equal to radical 3 over 2 times the base. So again, that area formula for that triangle is 1/2 base times height. The base is my upper minus lower, which we said was g of x minus f of x. The height, I'm going to use this ratio, so I'm going to say it's radical 3 over 2 times whatever I wrote for base, so g of x minus f of x. The area then is 1/2 whatever I wrote for base times whatever I wrote for height. So notice how I have two of these. So I'm going to say it's 1/2 times radical 3 over 2 times g of x minus f of x squared. And I can multiply that to get radical 3 over 4. So I'm going to say the volume is radical 3 over 4, the integral from a to b of g of x minus f of x squared. So I just pulled that coefficient out in front because obviously we can pull coefficients out. And that would be my setup, and it would be great if this was a calculator active question where I could just type these functions in. But sure enough, we'll get a lot of practice in class tomorrow, and look forward to seeing you then. Have a great night.